I'm Anil Kumar, and in this video I'm going to discuss behavior of a function near the vertical asymptotes. We'll have three examples. The first one is g of x equals to x plus 2 divided by x minus 1. Then we have b, f of x equals to 1 divided by x squared minus 2x minus 15. And then h of x equals to x divided by x plus 2 times x minus 3. So let's begin with the very first one, which is g of x plus 2 divided by x minus 1, right? So we'll not really sketch the function, but we'll concentrate more on vertical asymptote, right? Now, how do you find vertical asymptote? Let's look into that. So when we are talking about vertical asymptote, we can equate denominator to 0. Is that okay? X minus 1 is in the denominator. We say x minus 1 equals to 0 or x is equals to 1. Now here there is only one vertical asymptote, and that is that x equals to 1. So let us sketch it here. Let's say this is vertical asymptote at x equals to 1. So equation of this line is x equals to 1. It goes through x equals to 1. Perfect. Okay. Now when we say behavior of the function near vertical asymptote, we are trying to find that if x approaches 1 from left, that is from this side, we normally write with minus as an exponent kind of thing. So 1 with minus sign there on the right side or left side, it means from left. When x approaches 1 from the left side, from 0 side, then what happens to g of x? We know it goes to infinity, but whether it goes to positive or negative infinity, that is the idea. So let's substitute a value which is less than 1. So in our case, a value less than 1 could be, let us say we substitute g of less than 1 could be 0.9. Do you see that? Substitute a value and then check whether you get a positive answer or a negative answer. Now if I write 0.9 for x, then what do we get? We get 0.9 plus 2 over 0.9 minus 1. Clearly, numerator is positive, right? So we say numerator is positive. We're not really interested in the value. However, denominator is negative. Since that is the case, positive divided by negative should be negative, right? So that means g of x approaches negative infinity. So we denote it like this. It's going like this, downwards. So when you approach vertical asymptote from the left side, then the function approaches negative infinity. That's what we understand by vertical asymptote behavior near function. Now let us also figure out what happens when x approaches from the right side, that is x1 plus. This is from the right side. What happens to g of x? Now you don't really have to place a value like this. You can do mental calculations. So think about, so I'm just writing so that it helps, 1.1. So you know this is positive, this is also positive. So we are talking about positive over positive, so this will be positive infinity. And therefore, the function should go like this. Do you see that? So that is how the behavior is going to be for the given function as x approaches from left and right. Is it okay? So let's summarize the result for g of x. So we say when x approaches 1 from negative side, g of x approaches negative infinity. And when x approaches 1 from the positive side, g of x approaches positive infinity. Do you see that? And you know what the horizontal asymptote is? Ratio of these two. So horizontal asymptote will be kind of like this. And if you sketch the function, you can find x and y intercepts. Y intercept is 2 over minus 1, which is here. x-intercept is numerator 0, which is at -2. So you could sketch a function which is kind of like this. Do you see that? So you can see that behavior near the asymptote, it approaches towards negative infinity when approaching from left and positive infinity from right. So I hope the concept is clear. Now we can move on with the other two examples. Second example is f of x equals to 1 over x squared minus 2x minus 15. So at times you may have two factors. So we may write this as we are looking for product of 15 and sum of minus 15 I mean. So a negative and a positive number, x minus 5 times x plus 3 will work for us when you multiply minus 15 when you add minus 2. Now that clearly indicates that we have how many vertical asymptotes? One vertical asymptote is because of x minus 5. If you equate to 0, we get x equals to 5. And the other one is because of x plus 3. When you equate that to 0, you get x equals to minus 3. Is that okay? So that means if I want to sketch the function, then first thing, the vertical asymptotes will be at plus 5 and minus 3. Okay. And let's say this is minus 3 for us. So these are the vertical asymptotes. In this video, we'll concentrate on behavior near the vertical asymptotes. That is to say, we want to know first near, let's say, minus 3. So if x is approaching minus 3 from the left side, you understand now, from the left side, then what happens to the function? So what you can do is, you can place a value which is on the left side, let's say minus 3.1, right? More negative than 3, right? So if I place a value which is negative, we know this will be negative. And if it is more negative than minus 3, let's say minus 3.1, that is also negative. So two negatives will give us positive, right? So you'll find that f of x will approach positive infinity, correct? Because if I substitute a value, let us say minus 3.1, is it okay? Then this is negative, minus 3.1 minus 5. This also becomes negative. Minus 3.1 plus 3 will give me minus 0.1, right? We're not interested in value, but we are interested in sign. So we clearly get the answer that if you are approaching from minus side, then the function's value become negatively large. So that's the behavior, right? Now, if I substitute a value which is slightly more than minus 3, that is to the right side. So minus 3 with positive we write, that means on the right side. Then f of x is what? It is a negative value, so this remains negative. However, that becomes positive. So we are approaching negative infinity. Is it okay? So, oh sorry, first was positive infinity. I should have drawn that on the other side, right? So I'm sorry for that. Not this. This is positive infinity, right? When you are approaching from the right side, we are approaching negative infinity. So that will be like this, negative infinity. Okay. Now let's analyze what happens at the other vertical asymptote. So when x is approaching 5 from the left side, this means from the left side, in that case, f of x is approaching what? Left side means you can take a test value as 4.9. So this becomes negative, that is positive. So it is negative infinity, correct? Negative infinity means this side, correct? Now if I substitute x a value more than 5, let's say 4 plus, 5 plus, that means we are approaching from the right side. F of x will be what? Let's say 5.1. Let's take a value which is 5.1. You can actually calculate. So both are positive, so we get positive infinity. So in this case, the graph will be approaching positive infinity when you approach from the right side. Is it okay? Now this function, if you have to sketch, it's a parabola, kind of like this. I'm just sketching, correct? Without any details. And reciprocal of this will be, as you can clearly see, degree of denominator is higher, horizontal asymptote is the x-axis, correct? So this side positive reciprocal is positive, and on this side we have kind of like this. So that gives you the graph and also explains the behavior near the asymptotes. I hope that's absolutely clear. And let's move on to part C, which is, now we have a function h of x equals to x divided by x plus 2 times x minus 3. Now in this case, we again have two vertical asymptotes, right? So vertical asymptotes are at x plus 2 equals to 0, that is x equals to minus 2. The other one is x minus 3 equals to 0, that is at x equals to 3, correct? We are interested in finding behavior near the vertical asymptotes for these two, right? If you want to sketch it, we can just make a rough sketch here. Okay, so we have two vertical asymptotes, one at minus 2. The other one is at 3. Okay. So this is at, let me write minus 2 and 3 here. Okay. So behavior near minus 2, let's discuss. So we'll say what happens when x approaches minus 2 from the negative side. So if minus 2 negative, we could think about a number which is minus 2.1. In that case, what happens? So place a number in your equation. What happens? Is it negative or positive infinity? So minus 2 will make numerator negative, which is minus. Let me write minus here. This term, if I am writing value like, let me write h of minus 2.1. Okay. So this becomes negative, and here this is also negative. So 3 negatives means negative, right? So that means that the function is approaching, when you approach from left side, I should write minus 2 minus here. Okay. No, which I've written, sorry. Minus 2 minus, yeah. So it is approaching and giving us a negative. That is the behavior. Is it okay? Now what happens when we are approaching from the right side? That is this. So let's take a value which is like minus 1.9, for example. In that case, numerator is negative. As far as the denominator is concerned, the first term will be positive and this term will be negative. That gives us positive infinity, right? So we can write in this case, when x approaches from the right side, h of x approaches negative negative cancel plus infinity. So that is this. Is it okay? So that is the behavior. So let me summarize what we have learned from here. That is, when x approaches negative 2 from the left side, then h of x approaches negative infinity. When x approaches negative 2 from the right side, h of x approaches positive infinity. Correct? Now let's analyze behavior near 3. So same approach. What happens when x approaches positive 3 from the left side? In that case, you can substitute a value, let's say 2.9. Numerator is positive. Analyze first, right? So h 2.9, is it positive or negative? Numerator is positive. This one is also positive. However, that is negative, right? That is negative. So we get negative number here. So we can write h of x approaches negative infinity, and that is how you show. Now, if x approaches positive 3 from the right side, then what happens? then all of them are positive, right? And the result is that h of x approaches positive infinity, like this. Is it okay? So that is kind of behavior. You also know that the degree of denominator is higher, so horizontal asymptote will be the x-axis. When you sketch this function, knowing the behavior and the asymptotes, it will be kind of like this, right? X-axis is your horizontal asymptote, and here x equals to 0, it goes through the origin, and then like this. So from the behavior, you can actually sketch fairly accurate graph of a rational function. You'll also note here that horizontal asymptote is x-axis, however, we have an x-intercept. So that is also possible, right? So it is very important to understand that even if you have horizontal asymptote as x-axis, there could be x-intercept. That is to say, the curve could cross the horizontal asymptote line. The reason is very simple, and that is horizontal asymptote is defined at large values of x, not in between, right? That's the reason. Okay, anyway, our concentration is on vertical asymptotes, and I hope with the help of these three examples, we have understood how to find behavior of the function near the asymptotes. Thank you, and all the best.